Hey, what's up? So, welcome to a new emission. Let me check if you're listening well. Give me a moment. Okay. Let's see. Let me check if. Oh, welcome to a new emission. Let me check if you're listening well. Give me a moment. I think everything is well, at least. Um, let's see. Notify me. I don't know why Notify Me isn't working yet. Okay, let's check. Okay. Oop. Okay. Give me a moment. Alright, no. Let me go and change the description because I didn't add the Discord link actually. So let's click on welcome, invite, and let's edit, never, and copy. Okay. So let's go. Okay, let's start. So I want to make the robot like 130 for 180. Why? Because I want it to be the smallest possible to have more maneuver space. Sorry if I just doubt a lot when I'm speaking English because it isn't my native language. So I'm a Spanish I'm a Spanish speaker and that's it. So let's see. Okay, I have to add here. I have the area total of the robot here, so I have to add the wheels, the space. But I don't know how to edit this shit. Okay, I'm already editing this. So my wheels are like, I don't know. Let me check actually. My wheels are like 25 millimeters. 25. Let's add 30 per. Let's see. 77. So we're gonna add here 70. Like this. So 30 per 70. Okay. If you listen something that I said wrong or something like that, just let me know, because I want to improve my English for the next competitions. Or even if you don't listen very well what I'm saying right now. So let's check. In the front, I need to add more space, because for the steering system, I need to have space for the wheel to enter inside the chassis and outside. So I need more space. How more? I don't know. So let's add like 75 per 30. Actually, I will add 40. No, 30. It's okay. So 75 per 30. Oh, 30 per 75. Okay, that's it. So I have this now, but I also need space for the wheel will rotate from the center of the wheel through this and this direction. So I'm gonna need a line to change this. I have this and also this one. I don't know if this will be okay. I actually want to make a line, construction line, in the center of this, and also one here. So the construction lines are basically for guide you. I'm saying it right? Okay, I don't know. Are just for guide you and help you to put more components and geometrics here in more specific places. So I'm gonna need a line without the construction market, and I will need this, and also I will need this, and then here, and from here I'm gonna need this, and also I'm gonna need yes, this and this. So let's delete everything that it's not gonna be filled, like this. I have to delete this also. Okay, then this. I have to. Okay, I delete more. Okay, that's fine. This and this. Okay, so we're right here. Oh, also I'm gonna need to delete this one, those, and I think that's right. Let's go to solid. I'm gonna add a 5mm extrusion. So then what we need something to the rear wheels, the wheels that have the torque system, can spin, so the axis keep in place. So let's edit this upper sketch, and I have to project these two lines. Okay, this now. Okay, those. Let's project those. Okay, and let's add a construction line here in the center. Here, perfect. And also again this line, perfect. So then we're gonna need to add a rectangle right here, 20mm. I think it's pretty fine. 20 here also. Finish sketch, and then we are gonna add here and here 25mm. So we need this to be a circle. Why? Because it looks good. So let's add a circle of 10mm, the half part of the total diameter. So also we need this to have more supports, because I don't want it to broke when I'm in competition. So let's add here more geometry. Okay, like this, 5mm, and we have more mechanical resistance here. So also we need a hole here project, we need here a hole in the center of the circle of 20 millimeters. We need here to have 6 millimeters for the axis, but also we are 3D printing this part, so we need like tolerance for the material suspension that 3D printed have. So we are gonna add just 4.4 millimeters. So we add this, and let's go to solid, and extrude this to make a hole. Here we go. We have now the axis that we are using, the supports that we are using for the torque axis. So here we are. What's next? We need the supports for the all the. Okay, let me check. Give me a moment. We need the support for the steering system right here. Okay, that's pretty fine. We need to mirror this from this. Okay. Okay, solid. Let's just extrude this 5 millimeters. Okay. And also let's add here. Okay, no. Right now, no. Okay, we extrude this. Let's add here 5 millimeters. By the way. Okay, that's fine. That looks good. So now we're gonna add just right here. New sketch. A line. Right here. And also line right here. Nope, I don't like it. So let's add here like okay, here 0 degrees, rectangle, center rectangle. This is actually fine, but we need center rectangle without the construction. Okay. Have here 5 millimeters. We need 8 actually. And then we're gonna just need a rectangle here of 8 millimeters per 10 millimeters. And I don't know, let's add 15 millimeters. Okay. Also, we need here a line because I don't want everything to be filled up to the top. So we need here another line. And let's remove this one. Okay, that's fine. Let's mirror this shit. Okay, mirror this, and also this one. And mirror about this. Okay. Let's click OK. And start working. So here we're gonna add 20 millimeters. Then here, let's add 2 actually. And also from object. But no, select this. From object, this, and -2. So that's pretty good. Let's go here. 8. Okay. We also gonna just change this. 4. Okay, that's pretty fine. Let's also add here something to make it less like this. Okay, that's actually fine. Let's add here this one. Actually, I have to replicate this first. So 20, also 2 millimeters, and also okay, this one, but from object. Oh, sorry. Wait, -2. Wait, that's pretty fine. Then we did here this, 8 millimeters. Okay, and then we did here, and here 4 millimeters. Okay, that's pretty fine. Also, we are gonna do here, and here. Like this. Okay, that's fine. And also we're gonna do here and here. Wait, I like this. Okay, I think this is pretty fine. Also, we can just do something here to make it stronger. All of this is just to make this a little more stronger, because I don't want this to break at the middle of the competition, you know. I want it to keep the strongest possible. So here we go. We have here the wheel. I mean the holder of the wheel. Let's project this. Let's add here for M2, MT, and 4. Oh wait, 5 millimeters. So construction line again here. And a mirror here, here. Okay. Finish sketch. Solid. Okay, this looks good actually. I like this. Maybe I'm gonna do like a chamfer here and here. No, this one no. Wait, 10 millimeters, probably. $10 millimeters. Chamfer. 10. Okay. This looks good. Okay, so we need this. This. What else? Okay, the servo support. Let's search in internet. actually. SG90 dimensions. Okay, I hope those are millimeters. Okay, okay. Okay, let's take this one. Right here. Okay. What's this? Thermometer. Okay, servo motor. Okay. I need this. Those. I mean. Okay, so let's go here. Project. And I'm gonna need here. $22, 22.2. So nope. I need. Wait, no, that's fine. That's fine actually. Okay, this one also help. Okay, this is fine. That's good. Okay. 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 Fine. So let's start here. This one. Okay. 12. Oh, 12. Sorry. Sometimes I just speak Spanish. Okay, this looks good. Here will be the servo motor. Give me like 2 minutes. I'm gonna check if I have the servo here in my room and see if this is well positioned, because I'm not pretty sure where is the wire of the servo. So let me check. I can find my servo, but we're gonna trust in the reference image, so it's fine. Okay, we're gonna trust on it. Hmm. I don't know where I put it. Okay, so let's check. Check this. Okay, I mean, okay, I made it. Okay, I have to. I need to put all of this, but here. So yes. Okay. Let's see, where is it? I need to move this actually. Okay, this is working. Do everything again. No, actually, okay. Sketch. Okay. Let's see. Okay. if I have here the servo, I can just pass through this direction the rotation, the steering system. So let's see. Okay, let's do again this and this. Oh shit. Okay, let's say this one right here, and also right here. Finish. $16. Okay. Where is okay. 16, yes. Okay. 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 This is fine. Okay, so now we're just gonna need to add here something. We need the motor support, but first of all we need the gear that we're gonna use on this one. So let's go to utilities, add-ons, and sport gear. I think this is centered. So here we need to move this one again. I mean, it's fine there. Actually, it's pretty fine. Yes, it's fine. Let's make this second one. So the second gear is gonna be connected to the motor, so we need the same amount of tooths. I would like to put the same dimension of the gear, because if I just put the same, the torque of my motor and the speed is not gonna change, but also it is gonna be more complicated to put the motor to set it well. So let's see. I have here that the diameter of my motor is 3 millimeters. 3.1. Okay. Let's move this one 90 degrees. Okay. This is fine, I think. $45 por 12. Ah. 45 for 12 millimeters. So yeah, 3 millimeter. Okay, so this is my motor. So we have this here. Okay. Y más o menos a 8. 8. 8 plus 16 here. Also add this rounded part. Like it's like this. Okay. Mhm. Mhm. Okay, let's print everything. We have this here.
Losers always whine about their best. Winners go home and fuck the prom queen.
Okay. Fuck. So we have supports here, 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 and here. It is fine. Duration time 1 hour. 27 meters. 51 gram. Okay, that's fine. Let's see the. Okay, I like it. So let me just clean the printer and send to print. Out. Okay, let's go to device, K1 Max, and it's this one. Okay, let's start printing. Okay, give me a moment. Okay, I think the model is fine, and now it is printing here. So we can do something else. What about working on the ROS terminal on the ROS package? Okay, so let's do a WSL to enter the Linux Windows subsystem for Linux. Okay. Okay, that's fine. Let me show you also the first model I did. Not the first, one of the first models I tried for this competition. I think is this maybe. Yes. So at first I did this. Why? Because this is bigger. We have the reduction system here. We have the servo, a bigger servo actually. And also we have here the steering system. This steering system, here is the servo. There is the barbell. an axis here, and also there goes the wheel connected, and in this part and in this part goes a nail, yes, a nail, fastener, I don't know how to say it, but it goes here, and the servo just moved the axis here, but this doesn't have the motor holder, so I don't like it, and also it's too big. Why too big? Because I don't know, it's really big, I don't know why. So I decided to make a smaller version. This is 18 per 13 here. This is like 18 per 25 here. So that's why we make a new one. And also this is more professional, I think. This looks more compact and also resistant. So I like this. And here I have the problem that when steering, the wheel just touch this part of here. Yes. So with the new version, we have the angle here for the wheel steering. So that's pretty fine. And also we have here this for attaching the upside part, the second floor of the robot. Okay, so I like this. Okay, let's see how is it printing. Okay, this looks fine. Let me go to check in person. Actually, the first layer isn't that good. Isn't like total plain, but it works because it's just a prototype. So let's keep going here.
せるものか。僕は負けるわけにはいかないんだ。見ていてくれ。
Okay, let me explain this code. So first of all, we need some publishers. So we need a speed publisher and a turn publisher. Why? Because with the publisher, we're gonna send data to the steering system and the obstacle and the traction system. We're gonna say to them how much to turn and how much to run. You know. So also here we're gonna do self.move. The turning the turn for to help avoid the next obstacle. So yeah, I have to change the logic of this. So okay. So let's let's leave the stream here. So I'm gonna just focus on other things. I'm gonna leave the streaming, but just with the printing window. So I'm gonna come back in a few minutes and maybe I keep streaming or maybe no. I don't know. I have to rest my mind a little. Okay, so I'm gonna leave you with this here. Okay, you go. Okay. I'm back. Okay, just give me 1 second. I'm gonna. Oh, what? Okay, I'm gonna close my door and let's keep working. Okay. Okay. Let's see. Oh, what I was doing. Okay. It's a little cold here. Cold, cold, cold. I don't know. It's frozy. Okay, let's work. Let's let's work. Actually, I don't want to keep doing stuff like the ROS package right now because I want to start working on it when I have the new Raspberry and I also have the all the sensors connected and all the actuators connected. So I don't want to make it right now. I actually want to make like a website for me because I want to start selling 3D printing parts, robot kits, and that kind of things. I want to start selling it because I need money. I need a lot of money for competitions, so I'm gonna start making a business. So let's see how to make a website. I have a lot. I don't make a website in a lot of time. So let's see. It starts. Okay, let's open terminal. CD desktop, CD OneDrive, desktop, Haciel, ls, CD webdev, webdev. Okay, okay, so npx create next app arroba latest. Let's install following package. Okay. What is your project named? Okay. Octobots Robotics. Do you like to use TypeScript? Yes. Do you like to use a Slint? Yes. Tailwind CSS? Actually, I never learned how to use Tailwind. That's a little embarrassing. But let's use it. Why not? Do you like to code inside the src directory? Yes. Yeah, well. Oh, what if I did? Oh, do you subroute router? Yes. Turbo pack. Yes. Would you like to customize the import alias by default? No. Okay. Okay. Let's wait. I want to see how are you listening to the stream, so let me check right now. You're not listening a shit. Okay, let me change it. Let's go live. Let's click on play. Okay, here's it. Are you listening to the music right now? I don't know. Okay, let me check. Let me check a little. Right here. Let's go live. Let's click on play. Okay, here's it. Are you listening to the music right now? I don't know. Okay, let me check. Let me check a little. Right here. Let's go live. Let's click on play. Wait, I just removed the equalizer and the compressor of the mic because I was just hearing a little. Wait, you're listening double, right? Right. Wait, I just removed the equalizer. Okay, let's put to play again the music. I think I still sounding so forced when I speak English. I don't know why. I have to practice a lot, and that's why I decided to make this channel in English. Because I always, all the days I speak Spanish, so I don't have people to practice with when I'm speaking English. I don't have any other friends to speak English with, so all my friends speak Spanish. And I want to practice. I want to improve my English because when I go to a new competition in another country, okay, I forgot to quit the stream. I was saying when I have to go to another country, I have to speak English at all. I mean, for world skills competition, I have to speak English. All the instructions are in English, and quite everything is in English. So I have to learn English. Most not learn. I have to start speaking it more because I still sounding a lot forced. I don't sound natural when I'm speaking English. So it will help. It will help me a lot if you just correct me in the comments, or if you also joins to my Discord. I'm gonna speak when I'm streaming, when I'm recording, when I'm designing a road, so we can do it without problems. Also, I have to improve my listening abilities, and I don't know. That's quite what I have to do. I want to speak a little. I don't have a camera. I have a camera, but I don't want to turn it on because my room is a mess. I am a mess. I don't wash myself in yesterday, so I want to wash myself today. I don't know why I'm saying this. So I don't want to turn on my camera right now, but I want to talk a little about robotics in general. Um, my journey in robotics was a completely mess. When I just entered on high school, I met a teacher, my technology teacher. So I was taking his class. I've been coding since like I don't know how many years, like 8 years, 10 years, maybe. I started coding when I was a child, practically. I've been like 8 years old, maybe when I started coding, when my mom brought me my first computer. So I started coding for Minecraft mods on Java, but I mean I was 8 years old, so I don't have any idea of what I'm doing. So then I go to JavaScript for creating Discord bots. So I start creating Discord bots. I feel pretty good. In that moment, probably I was like 10 years old, but I don't feel the the action. I don't feel it quite good to me. So I moved to C Sharp and web dev. Web dev, I hate web dev when frontend means, because I'm quite bad designing webs. I'm quite bad on CSS and style sheets things. But backend, I love backend because you need a lot of logic, a lot of security process, and I quite love backend. Okay, but so I test with backend, I like it. I test with frontend, I hate it. And then I discovered a new game called Broke Protocol. It is an indie game. Right now it's quite dead, but I like play it sometimes. I, I just met it. I just discovered it and start doing modding, because this indie game has a modding stuff and a modding system. So we started doing modding plugins, coding on C Sharp and .NET language. So I started .NET there. Then I started with backend on .NET, and then I found robotics. That's the story I want to tell at the start. I entered to high school like when I was 15 years old, and I have this stage class. And yeah, I was quite involved on all the technology that a computer has. So for me, that class were boring, were too boring. So I just to the professor. I knew that the professor has a lot of projects about robotics on World Educative Robotics somewhere with Abilix Kit. So I told him, "Hey, professor, your class is a shit. Your class is a lot boring. I don't want to be here. So just give me a project and I will do it. I don't care which type of project is. If you want me to make a web, if you want me to make a robot, if you want me to make a completely app, because on that time I was just coding with things like Android Studio." So I said that I told him that I don't want to be in his class. So when I told him that I don't want to be in his class, he say, "Okay, don't be here. Just give me some weeks, and I will think on a project that you can do." So he think on a project. The next week he didn't tell me anything, and I keep on every class I have with him. I keep telling him, "Hey, I don't want to be here. Every class, I want a project. I want a project. I want a project. I want a project." And one day, the teacher just come with me and say, "Hey, I have this project. This is a world skills competition on Mexico. You have to make a robot. You don't have you have to code. I don't know where you have to code, because he didn't know a lot about robotics, like outside the outside the war the Ablix robotics kit. So he didn't know how to code a robot from scratch, and I also didn't know how to code a robot from scratch. But I did Python. I didn't know Python. I didn't know Java. So he told me, "Come here and work with me. Come make a robot, and I will send you off your class." So we started working on the robot. The first robot was a completely shit, just like a sphere with two wheels. that crashes on every wall that he found. So the first competition didn't go quite well, but we entered on the 8 better teams. So in the 8 better teams, we passed to the next stage. That was the World Skills Finals of my country, of Mexico. So I improved the robot a little, not too much. It is still being a mess of robot because we don't have the resources. We on that time don't have a 3D printer. We don't have like money to buy one or the knowledge to have one. So we didn't know. So we created this new robot, and when we created it, I feel very proud, and I think I found a love on robotics. That was love on first sight. So we compete and we won. Our robot was horrible. Our robot was a mess, but he did the job. He completed the challenge, and he did it better than any other robot in the competition. So he won. We won. Then World Skills organizer told us that we are selected to the next stage. We are selected to an international capacitation. I don't know how to say that. Another country where we were. I don't know how to say. In past, we were gonna learn from other competitors. So we go to this country international capacitation. Yes, I know. That thing. So we went there, and we start learning. We have courses and that things. Then they told us, "Hey, you're selected for the international stage of World Skills." So we started working with the World Skills kit, with the Studica kit. We started making robots, making prototypes, making a lot of things. And our robot again was a mess. I committed a lot of errors. I just coded really bad, and also my assembler, my mechanical teammate, he didn't work at all. I made everything, so that was something that just made me feel quite bad. So we go to World Skills International. We of course we lost. We failed all the challenge, all of them. Every single challenge we failed it. So yeah. Since that competition, I fell in love again with robotics, but not robotics like the previous competition. Robotics in the international way. Enter a stadium, see thousands of people screaming, saying the name of your country, slapping, and the presenter just say Mexico on the microphone, and you and your team just walking through a passerelle and seeing all the people, seeing all other countries, the music, the lights, the life, and your family in your country, your friends in your country, just giving you forces through the chat, and that was amazing and completely new feeling. So I fell in love again. So I decided to keep working on robotics. So I started learning about ROS, about 3D printing, about a lot of things. I bought my first 3D printer. I bought then my next 3D printer. That is this one that you are seeing, K1 Max. So I started doing robots, and then CCT General, the CCT Guanajuato, my country, my state school, the direction of all these schools with the same subsystem in the state, told me, "Hey, you are the guy who went to France to well, how to say that, to France to represent your country. So we want you to represent Guanajuato on the net CCT national stage for Coahuila for robotics. A line follower with multiple line colors. I did it. I did it with a camera, and we won the second place, not the first. That was a completely stole first place. We deserve to win the first place, but you know the winners don't put excuses, and the losers just make them better. So we lost that competition on second place. We got on podium, and they gave us a pass to the next stage of the to the national stage of WRO competition, World Robotic Olympiad. So here we are. We have a competition in the door the next September, where we have to make a autonomous robot that just follow a track, and that's it. So that's my journey on robotics. I didn't say all that I want to say because I'm speaking English and I know how to express myself quite well, but that's it. So let me go through for water, and I keep talking, we keep coding, and we keep doing things, okay? Let me go. I'm back again. So now I want to go to eat something. So we're gonna keep the streaming later, or maybe record some video. I don't know. But I'm gonna say goodbye. I hope I go back when the printing use is finished, and we can start making more printing. And I'm gonna test the parts on the part. Okay, so on the printer. So let's see you later, guys.